our dear parents and students of SS3. I trust you are staying safe and away from the virus. I know your answer is yes. Please keep on doing that. Keep yourselves as safe as possible. And do not just keep yourselves safe, you should also be focused. Remember, our WAEC SS3 and NECO SS3 is inevitable. It's an exam you're going to take when all this lockdown and pandemic is over, because surely it will end. But still, while waiting for it to end, you need to stay focused, you need to stay sharp, sharpen your mathematical skills, and not just your mathematical skills, other subjects of your endeavor. This is the reason we are reaching out to you. Our school is reaching out to you through this means, because as a maths teacher, I will not have you forget all what you've been taught for about a session that we've been together preparing for these exams. So for today, we're going to start our first mathematics class. My name is Ernest Bassi, and I am the Vice Principal Administration of this great college. The topic of our lesson today is longitude and latitude. The class will be on for about 30 minutes. Pardon me for that interruption. The objectives of this class is, first of all, uh, we describe the shape of the Earth, which I'm sure many of you are already familiar with it. Identify the different hemispheres. Distinguish between the lines of longitude and the lines of latitude. The fourth objective is distinguish between great circles and small or lesser circles. In our previous classes, before the lockdown, the pandemic started, and we had to close school, we were taught graphs of trigonometrical ratios. We discussed trig ratio, which is just a piece of cake for all of you, as our tangent, cosine, and sine. We also discussed graphs of sine, cosine, and tangent functions. Then lastly, we did graphs of, as in trigonometrical graphs, which is your composite graphs. All these things were discussed. I would not have you forget them. You know that every year WAEC always puts in a graph question, and that is 12 precious marks. So I will not have you forget this. Let's go into the topic proper. The first part of this lesson I want you to know is that the shape of the Earth, as observed from space, is approximately spherical. It's called a globe. It's not purely round, nor is it an oval shape like an egg. The Earth has a radius varying between 6,300 kilometers and 6,400 kilometers. Our next subheading is the axis of the Earth. This is plural for axis. The Earth has two major axes. These are the north-south axis and east-west axis. The north-south axis is also called the polar axis because it houses the north and south poles. Let me remind you that the Earth makes one complete rotation in 24 hours. And it is believed that for an object, a round object to rotate, it rotates on its axis. So the Earth has an axis, the axis of the Earth. This is an imaginary line anyway, running from the North Pole through the center of the Earth down to the South Pole. And this north-south axis houses two hemispheres, which is the northern hemisphere and the southern hemisphere. The east-west axis, much like the north-south axis, it runs from the east it runs in the east-west direction. It also divides the Earth. This particular axis has two hemispheres. So we are talking about the eastern hemispheres and the western hemisphere. Great circles and lesser circles. Some books use small circle radius. So when I talk about lesser circles, I'm referring to small circles. I will not have you be confused. A great circle radius refers to when a cut or sliced object still retains the radius of the initial or prototype object. I'll take it again. A great circle radius refers to when a cut or sliced object still retains the radius of the initial or prototype object. I will explain all this. Just give me some time. Lesser or small circle radius is when the cut or sliced object has a radius smaller than the initial or prototype object. I'll take it again. Lesser or small circle radius is when the cut or sliced object has a radius smaller than the initial or prototype object. Let me explain this by using a diagram. It will make sense. And I decided, let me use something that all of us are very familiar with. All of us know orange fruits, right? Now, an orange is a perfect sphere, as in it's perfectly spherical. So that object there in figure 1 is an orange. I had to put up that sketch. Now, as you can see, there's a divide on that orange, and that cut is made, that cut or slice is made right at the center of that orange. As in, if you could trace that kind of location on an orange, just make that a cut there. And look at figure 1C. Figure 1C shows you the cut fully. So what you are seeing is a circle, an orange fruit divided into two equal halves. Now, when this cut is done, let's look at the next slide. It will look like this. So this is the inner edible part of the orange. But you will observe that this cut, which is half of it, still retains the radius or maybe even the circumference of the initial orange fruit. Why? Because you are cutting it right at its middle. So that middle cut, when you look at this inner edible part, it retains the same circumference as the initial orange fruit. Meaning, if it has the same circumference, it definitely has the same radius. Now, this radius of the cut in the middle of the orange is a great circle radius. Why? Because it retains the radius of the initial or prototype object. Let's go back to that definition I gave you earlier. That great circle radius refers to when a cut or sliced object still retains the radius of the initial or prototype object. Are we good? I trust we should be okay. Let's look at another diagram, still to buttress this. Still an orange fruit, but this time around, the slice is made on the upper parts of the orange. So look at, that's for D, look at E. This is what the cut will look like. And if you look at it very well, the lower section is larger than the upper section. So when you have this cut, you will still have this shape. But you will observe that this time around, when the cut is still round, it's still a circle, mind you. But the cut this time around, still a circle. But the particular cut will be smaller in circumference than the initial object. When the when the slice of the orange fruit is smaller than the circumference of the initial object, we begin to talk about lesser, lesser, lesser circle radiuses. Are we good? I want to believe so. Let's proceed. The next subsection we are going into is lines of longitude and latitude. Let me lower the screen so that you can see something there. All right. Lines of longitude and latitude. These are imaginary lines used to define given positions on the surface of the earth. Now, saying what I've just said now, as in reading what I've just read now, most of the GPS we are using military technology where maybe Americans or Israelis will locate and destroy certain objectives on the Earth's surface. This is what they use. They use these imaginary lines called lines of longitude and latitude to make out coordinates of certain objectives which they want to destroy. That's how they're able to throw missiles beyond visual range, and they're able to score the hits they are getting because they have marked out the coordinates of this particular points on the Earth's surface. So these are longitude and latitude. These are imaginary lines used to define given positions on the Earth's surface. Uh, Let me pick something here. I'll adjust my camera. The horizontal lines you are seeing here, these are my lines of latitude. They are horizontal lines that cross the Earth's surface. Those are my lines of latitude. I'll take it off. The vertical lines you're seeing here, these are my lines of longitude, and they cross the Earth's surface. A coordinate is gotten at the point of intersection of the two lines. So like this particular location, I'll take it off first. This particular location, which houses the intersection of the two lines. Your lines of latitude and your lines of longitude. Where they cross, that's a coordinate. So these are imaginary lines that give positions that are used to define given positions on the Earth's surface. I hope we are good on that. That's something I just want you to know. All right. Let's talk about lines of latitude proper. I'll adjust my camera again. Lines of latitude divide the Earth into northern and southern hemispheres. The equator is the largest of the latitudes. I'll come to this. The equator is a great circle. I talked about great circles earlier. Then all other latitudes are lesser or small circles. Let me show you what I mean. Let me adjust my camera. Okay. Now, this is your equator. I said your equator is the largest, the longest of all the latitudes. Look at another latitude here. It's long also, but not as long as this one. I've even done some extensions on it. I'll do it again. That's your equator. Look at this other one. It's long, but not as long. So of all the latitudes, the equator is the longest. Then from your equator, you know northern hemisphere and you also know southern hemisphere, not just the equator. From your latitude, you can know your northern hemisphere and your southern hemisphere. I said also that the equator is a great circle. As you can see, if if you were to if you were to cut the earth, if it were possible to cut the earth at the equator, you will observe that when you cut the earth, the shape you're going to have will still retain the same radius. It will still retain the same radius as the initial shape of the earth. I hope we are good on that. Okay. I also said that the equator is used to measure other latitudes. We'll talk about this in calculations when we when we start when we do our second class, because in that particular class there will be lots of diagrams and calculations. So this is just to the introductory part to put you through on certain things. So let's go back to this last point before I came on this. Sorry, let's go back to our second to the last point, because I'm not sure I was done there. Now I said that the equator is a great circle, like I showed you earlier. All other latitudes are lesser circles. They are smaller circles. They are not as large as the equator. So please note that. Then the equator is used, that's the last point, to measure other latitudes. Like I told you earlier, we'll discuss this better in our next class. Let's go to longitudes. For our lines of longitudes, let me adjust my camera. For our lines of longitudes, the lines of longitudes divide the Earth into eastern and western hemispheres. They converge at the north and south poles. They are not parallel lines. Let's look at this. I'm adjusting my camera again. Now, look at what I said earlier. All of the latitudes, the longitudes rather, they seem to converge. They converge, not seem to converge. They converge on the northern and southern hemispheres. If you look at the longitudes, also, they are all great circles. Unlike the latitudes, only the equator is a great circle. But in the longitudes, all of them are great circles. All of them. They are also called meridians. So in case you see a wire question or an echo question talking about meridians, please, it's something you already know. It's just another name for longitudes. Nothing serious there. The prime meridian is the Greenwich meridian. This is on longitude 0 degrees east and 0 degrees west. There's something I did not talk about in the latitudes, but from here I'm going to raise that point now. Now I said that the prime meridian is the Greenwich meridian, and that is 0 degrees east and or 0 degrees west. Now what I want to say is for the Greenwich being 0 degrees east, 0 degrees west. Some books use east, some books use west. But what matters is the 0 degrees. And when you see a coordinate using east or west, please, it is a longitude. Don't even think too hard. Just east or west is a longitude. Remember, the longitudes divide the Earth into eastern and western hemispheres. Let me pick a point I missed out. I said that the equator is, I'm going back now, the equator is the largest of the latitudes, and it is on latitude 0 degrees north and 0 degrees south. I told you that the latitudes divide the Earth into northern and southern hemispheres. Now, once you see 0 degrees north or maybe 0 degrees south, it depends on the textbook, as in the author, how he wants to do it. But the important thing is the equator divides the Earth into north and south. So when you see north and south, Please, it is a latitude. It is a latitude. Latitudes divide the Earth into northern and southern hemispheres, while longitudes divide the Earth into eastern and western hemispheres. So when you see not maybe you see a particular latitude on 30 degrees north, please, it is a latitude. Or maybe 25 degrees south, it is a latitude. Maybe you see another coordinate, maybe 35 degrees east, it is a longitude. Or maybe 40 degrees west, it is a longitude. Do not forget this. It's good you have this in your mind. Then also, just like the longitude, just like the equator, rather, the Greenwich meridian is used to measure other longitudes. It's good you have these facts right, because when you have these facts right, it will help you. It will help you in your calculations, because I've seen students misunderstand these concepts which I'm putting right, so that you can see certain questions framed for you. You know, hey, they are talking about longitudes. They want us to calculate the particular angle from the equator and what have you, so that it's good you understand this concept about great circles, lesser circles, then characteristics of longitudes and latitudes. So once you see all these concepts, they should be on your mind. The next part of our classes will be calculation based, and not just calculations. We will also be making lots of diagrams, because without putting forth proper and correct diagrams, you cannot score complete marks in a longitude and latitude question, even when your solutions ends up being correct. Without proper diagrams to buttress your calculation, you are not going to score full marks. And again, also, without correct diagrams, it is more than you have a less than 60% chance of even scoring that particular problem. So it's good we understand all these concepts, so that when we start diagrams and calculations proper, we will not be walking amiss. We'll just make sure we score the needed points which we need. Now, this is a mathematics class, and if you did understand what I have just the class I've just given to you, I'll be very happy. But in case you don't, there are channels you can lay your questions to me. I'll be very happy to answer them. And don't be fooled to think, that this class there was no calculation. Don't worry, it's coming. But before the calculations start coming, it's good we understand these particular concepts and put ourselves on the right track. Take some assignments. The first one here is mention 4 characteristics each of lines of longitude and latitude. What is a great circle? Just use your own words. Say it in your own words. Then the third one is, what is a lesser circle radius? Thank you for your time. Remain blessed until we have our next class. Please stay safe. God bless you.